Okay, so basically we have a force being exerted on our door, and so if you want to find the torque, the proper way to do this is you want to set all the torques equal. You want to set up the torques, and so it would be torque of the hinge plus torque of the force we're applying. The formula for force is torque is equal to force times like the distance from it, right? Force times d. And so let's say our hinge, right? Let's say we have a force of a hinge, and what's our distance from the basically whenever you do a torque pump you want to set up a place where you are it's like an origin, right? And so our origin, they told us it's going to be at the hinge, it's at the axis of rotation. That's another way of saying it. So how far is that hinge from the axis of rotation? Bro, he is the hinge, so he's 0. And then our force, right? And so this is where I hated torque, because people will be like, oh, it's just force time displacement, but we get this freaking angle right here, so how are you going to do it? And so it took me so long to realize this. Basically, they always say find the thing perpendicular from the axis of rotation. Like, what does that even mean? And so right here, we want to find this right here. We want to find that, or you could say the other way, right? But we want to say, because he's already moving that way, we're gonna write it like that. And so we want to find this force. And so if our force right here, right? Let me draw that right here. If our force right here is 300 newtons, and this is 60 degrees, then using sine SOHCAHTOA, right? Whatever, sine of opposite over hypotenuse, that angle right here, or that force being exerted this in this way, will be sine of 60, 300 newtons. And you're gonna get 519. No, my bad. That's the force, right? And so our force right here is gonna be 300 sine of 60. And so now we want to see our displacement. How far is it? So if we're exerting a force right here, how far is it from our axis, right? It's just, they already told us it's 2 meters. So that's it, 2 meters. And you're gonna get 519.6 newtons. Another way of figuring this out, right? I don't use this a lot, but you could do it. It makes sense as well. You want to find, it's like the shortest distance from the origin to the where you're acting, right? So if we're acting right here and right here, we want to make like a right triangle. So let's say we're moving like that, and then we move this right here. We could just find the distance. So um it would be um 300. So the way you do it is, this is like, it's torque is equal to force times the lever arm. And so if I think you don't even need to do sine anymore. I think it's just 300 newtons, what they gave you, right? And then whatever that distance is. And so if our distance, so basically, yeah. Okay, I got you. So if this is like, if you were to draw a triangle now, we just want to find this distance x right here, and that we could just plug in for L. And so yeah, so if you just make it a triangle, right? Like that. And this is 2 meters, and this is x. Um, the way you're supposed to figure it out, right, is, okay. So this will be 60 Newton. This will be 60 degrees, and so if we already have 60 degrees and we already have that, we could figure what that is. And so I'm pretty sure it would be. I'm sure that makes sense of that. Yeah. So this is the hypotenuse. Yeah, it's the same thing. It's sine, right? It's gonna be sine of, like, imagine thinking of sine of opposite, which is x, over hypotenuse, which is 2. So it'd be 2 meters sine of 60. So then you plug that in right here. 2 sine of 60. I hope I'm right. I think that's what you do. And then 300. 2 sine of 60. And you're gonna get the same answer, right? 519. So that's another way to do it. So you could do either or. Yeah, it doesn't really matter. Okay, part B. Suppose a wedge is placed. Okay, so we have this. I'm gonna draw the whole thing, right? We're exerting a force. We're exerting a force right here, and so we already know our force, right? So this is our force right here. We're applying is 500. No, it's 519.6. Okay, so let's say we have a wedge, and so if we're moving this way, okay, we have our hinge right here, and we have a wedge. Imagine like a door stopper, right? This is a door stopper. If we're pushing this way, a door stopper is gonna be pushing the other way. So we could put a door stopper right like here. And so if we're moving this way, he's going to be moving this way. And so you could use your clockwise, non-clockwise thing to figure it out. But if you just use basic like torque, right? Torque of the hinge, plus torque of whatever, I don't know, the door stopper. Um, what is it called? What is it? A wedge? Yeah, a wedge. And then plus torque of force. This is gonna be zero, right? We already said it's zero. And basically we're saying what force is the wedge gonna apply where we're not gonna go anywhere. You know, it's too strong. And so obviously you could set it up force times the wedge distance. They said that the wedge distance is 1.5, and then we already know our force. So if we're like, think about it, if our wedge is going this way and then we're going this way, this is positive, right? Non-clockwise, this is negative. Doesn't really matter. You're gonna set them equal to each other either way. So 519.61, and our force you're gonna get is 300. I think it's like 300. Yeah, 346. 346.41 newtons. Yeah, that's the answer. So that's really it.